My name is Ellen Shiner from the First Parish in Bedford, and we'd like to welcome you to the first of the 2020-2021 Lyceum Lecture Series. This is a community forum on the arts, science, spirituality, justice, almost any topic. It's made possible by the First Parish in Bedford Unitarian Universalist Church. And next slide, please. So today we're honored to have Dr. Ann Kiessling speak to us about COVID-19, where we are now. Just a brief intro. Dr. Kiessling is the director of the Bedford Research Foundation, and she is a reproductive biologist who's made significant contributions in research on viruses and parthenogenic stem cells. She was one of the first AIDS researchers. And was that in the United States or worldwide?
The US.
Very good. And she remains one of the most important research biologists in the country. She's especially known for her discovery of reverse transcriptase in normal human cells. So thank you very much for joining us, and take it away, Anne.
Oh, thank you. I'm actually delighted to be here. I'm delighted to be with you. We've done a number of lyceums in the past, and it's always fun. It forces me to get together some data that I should have had together a couple of weeks ago, and now I've put it together so we can talk about it today. I thought I would do a combination of some biology and some, how do I get back to screen sharing if I'm, oh, here we go. If I'm a participant and not the, I'm going to do some biology, but I'm also going to do some stats, which I think are interesting for a number of reasons. All right. So we are now about 6 months into this pandemic. I don't think any of us realized exactly what was going to hit us in January when we saw the first cases coming. And we got the foundation involved in late February. Because and I'll describe that a little bit more. The Food and Drug Administration put out an email to all of the federally licensed labs in the country that if you were a federally licensed lab, and the word for that is CLIA, they were giving you a list of tasks they wanted you to do because they wanted everybody in the country who could to develop a test for the virus. For SARS-CoV-2 as we know it. SARS stands for Severe Acute Respiratory Syndrome. And this is the second time this class of virus has hit the world. The first time was in 2003, but the Chinese were able to contain it in China. They've been working on this virus for a while, and we'll talk about that in a little bit. So we decided that we could do this. We had been doing this kind of high complexity testing for HIV disease. As Ellen mentioned, this is not my first pandemic. And so it was going to be a matter of simply just kind of rolling up your sleeves and getting that assay converted to a SARS assay. And we made a decision as a lab to do that, not really knowing, I don't think, what we were getting ourselves into. Last week, we just passed 13,000 SARS tests, which is a lot for a lab that's designed to do them in dozens, not thousands. Although I'm glad we did it. So the reason that the Food and Drug Administration had to put out that cry for help is because of the basics behind the way our public health service is set up. And our country's public health service has been warned for several decades now that it was not prepared for a pandemic. It is not decentralized or centralized enough. And these cautionary tones have been public health people, not necessarily people in government. The public health experts have been concerned about the lack of an ability for our Centers for Disease Control to manage a pandemic because their laboratory resources are so limited. And we can talk about that a little bit. So here's one of the best places I have found to get coronavirus information is the Johns Hopkins Coronavirus Dashboard. And that is coronavirus.jhu.edu. Johns Hopkins is probably one of the premier public health universities in the world. They've been doing this for a very long time. And so they are updating the stats daily. So as of this morning, actually, there are 30,814,638 confirmed cases. And we have almost a million deaths. The death rate, however you want to know globally, is 3%. And although that's a scary number, it's not nearly as scary as something like Ebola, which is 50% or 80%. So in fact, the death rate, the mortality rate from this particular coronavirus is not that high. In the US, we've had 6.7 million cases, almost 200,000 deaths. We'll get to 200,000 deaths by the end of next week, probably. And we're sort of at the global overall 3% for fatality rate. And I put Sweden on here because Sweden and Israel, because they are countries of about the same size. They're both about 10 million people. Sweden has a national healthcare system, and they are a very sophisticated healthcare system. They decided early on that they were not going to close schools. They were going to keep their grade schools open. So schools for anybody 16 and under stayed open, and they closed the universities, and they closed the last 2 years of high school. And they went through a lot of deaths early on. These 5,865 deaths are mostly in their long-term care facilities. So there's speculation that what the Swedish government did, because they have a national healthcare system, they are very good and experienced at managing risk-benefit ratios. And it's speculated that they decided what they wanted to do was get as much of the country infected and build up the term there everybody's using is herd immunity as quickly as possible. And that seems to be what they've done, because now they are not suffering the second surge in cases that the rest of Europe is. So these are all risk-benefit ratios. Israel, on the other hand, has had many fewer cases, many fewer deaths, and it isn't clear exactly why, because I think the healthcare systems in these two countries is similar. I want to point out here what China has done. So China is only claiming 90,000 cases. Now, that can't be full disclosure because Wuhan, which is a population of 10 million people just in Wuhan, which is where the virus undoubtedly originated, shut down travel between Wuhan and much of the rest of the country in January. So China cannot have been limited only to 90,000 cases with only 4,000 deaths. It isn't clear why they're doing that. Now, if you look around the US, the fatality reports are kind of all over. If you look at San Francisco, for instance, they're reporting less than a 1% fatality rate, whereas Massachusetts, one of the counties down at the bottom of this page, one of the counties in Massachusetts has a 10% fatality rate. And I don't know what's happened to my pointer. So we'll just have to go down this line by line. So by and large, on the West Coast, the fatality rates are a bit lower. And on the East Coast, sort of starting with Detroit and Philadelphia, as you go down, you'll see the fatality rates are getting higher. Queens, New York itself are above 8% of reported cases. And Massachusetts is really quite high. We're at an average of about 6%, I believe. No particular explanation for that I can find. It could be the way things are reported. It's possible. The Mass Department of Public Health, which made some big mistakes early on, is trying very hard now to stay on top of things. You tend to wonder as a biologist if we're looking at different strains of the virus. The East Coast virus, particularly the one that spread around Boston in March, turns out to have come from Europe. It's not a virus that came in directly from Wuhan. Whereas on the West Coast, the early reports, the one out of Seattle, where that long-term care facility was so affected, that is a Chinese virus directly from Wuhan. These kinds of studies are actually being done by our Broad Institute at MIT, and they're mapping the virus as it moves around by doing fine-tuned genetics. It isn't that this virus is mutating at a rapid rate, it's that you can tell by very tiny changes in the virus genetic information where it came from. I also want to point out Washington, D.C. And Detroit. So Detroit has an 8.7% fatality rate, which agrees with the fact that the Black and Hispanic community seems to be higher hit in terms of fatality by this virus. But that's not true for Washington, D.C., which is only 4% fatality. And Washington, D.C. is 98% Black. So I think that we're part of these variation in these numbers. It has to do with reporting, undoubtedly, and has to do with how much testing you do. Obviously, the more people that you test that don't have symptoms, the lower your fatality rate is going to be. Because people who test positive but don't get sick, obviously also don't die. So the more testing that's done, the lower the fatality rate is going to be. And right now, it's running right around 3 to 4% worldwide. Now, to compare that to the flu, what everybody I think is trying to do is get a handle on how does this compare to stuff that we know, right? And so the CDC estimates that for last year's flu season, for 2019 and 2020, there was somewhere between 39 to 56 million cases of influenza. And there was somewhere between 24,000 to 62,000 deaths. And these are honest reporting measures because they have about half a dozen centers around the country that they rely on to generate this data, and then they extrapolate from there. So that means that the flu annually has on the order of about a 0.1% fatality rate, and that's with approximately 50% of the US population vaccinated. Now, last year, the CDC estimates that the vaccine was 29% effective. And what I learned just getting this data together for you guys today is that 29% effective is not effective against infection. It's 29% effective in keeping people out of the hospital. All right, so being vaccinated doesn't mean that you're not going to get the flu. It just means that you're not going to get as sick. So I'm sure that's why all of the healthcare workers are really hoping that everybody gets vaccinated. But it's not that you're not going to get the flu. It's that you're not going to end up in the hospital. Now, we're going to talk about vaccines a little bit, although I'm definitely not an expert in vaccines. But one of the problems that the flu virus presents to people who want to develop a vaccine is that, unlike other viruses, this virus binds to lots of different types of cells. It can infect lots of different types of cells, and it doesn't have a specific place that it attaches to the cell. So as you can see here on the, wish I hadn't lost my pointer. You can see here on the screen that the virus gets into the cell and then it takes over the cell's machinery. We won't need to go into that detail, except each one of those errors in that diagram represents a place that you could develop a drug against the virus. So the arrows in that diagram are all virus-specific processes. What's happening down at the bottom of that schematic is the viruses are getting produced and they're budding off the cell. Now, how bad a viral infection is depends largely on how fast an infected cell can make new virus particles. Obviously, if each cell is making 10,000 virus particles a minute, the titer of virus in your body is going to rise very fast. If it's only making 10 virus particles a minute, which is about what HIV does, then the virus concentration in your body is going to be very slow. So the rate of replication, the rate of making new virus particles is a major player in how serious a disease is and how rapidly it spreads from person to person. So this is just the Centers for Disease Control picture of how effective the flu vaccine has been. And as I mentioned earlier, effectiveness is not keeping people from getting the flu. It's the effectiveness is keeping people from going to the hospital. All right. So in 2015 to 2016, it kept about half of people who got infected out of the hospital. Last year, it only kept about 29% of people who got infected out of the hospital. Tony Fauci has now said making it, so in some ways you can look at a graph like this and say, well, this is not a very effective way to control this infection. On the other hand, not so many people die of it anymore, so it's kind of gotten off of everybody's radar. According to Mary Lou Sutters the other day at the president's newscast, in the 2019 to 2020 flu season in Massachusetts, there were over 40,000 cases of flu and about 6,600 deaths. Now, depending upon exactly how many cases, that's a death rate that's quite a bit higher than the 0.1% the CDC estimates. Massachusetts, she says, has become a leader in childhood flu immunizations. So now in Massachusetts, you cannot go to a public K through 12 school without being immunized against the flu. And this has been a bit problematic because some years the vaccine that is delivered as a nasal spray has been pretty effective, but not all years. And so if you have to immunize all children, that means you've got to get a lot of people organized who know how to do an injection. And so it's probable that most children are getting immunized in the pediatrician's office. I do believe that this year, the supply of flu vaccine seems to be pretty robust. And so I don't think we're going to have trouble getting everybody immunized. And I guess they have extended this to all public colleges and universities. It's not clear whether you can make this kind of a mandate for private universities. Now, because the vaccine is not very efficacious, that it seems like there would be more flu medicines, and there are 4. And none of these are particularly effective, but it's a really good idea. And 3 of them block the same stage in the virus replication. So they're all designed to keep the virus from multiplying. The one down at the second one, Xofluza, is designed to block an earlier stage of the virus, but there are people who don't think it does anything at all. So these medicines have been tested by giving them to large numbers of people, and actually they've had volunteers willing to be infected with the virus just to see how well these work. These medications are mostly used in individuals who have already been vaccinated. So it isn't clear if these medications would work well for a brand new infection that nobody had ever seen. But for people who are vaccinated, these medications are not working very much better than not taking them at all. Obviously, given the huge overall health impact of the flu and the fact that the vaccine doesn't block infection, it would be really useful to put some resources into new medications. So the take-home message for where we are right now with COVID-19, so the name of the virus is SARS-CoV-2. It was named by the World Health Organization. The name of the disease that it causes is COVID-19 for COVID 2019. And COVID stands for coronavirus-induced disease. And so it's COVID-19 that puts people in the hospital. So although the fatality rate has been extraordinary and the fear around this virus has been extraordinary, it really has a pretty low fatality rate, especially when you compare it to something like Ebola virus, for which, depending upon where the outbreak was, 30 to 90% of people die. Now, the public health ramifications of a virus in which everybody dies is that it also then doesn't get spread around. You get this, you get acutely ill, and you die. For a virus like SARS-CoV-2, where you are infected 3 to 5 to 7 days before you have any symptoms, that virus then can be widespread. I think the most realistic expectations for a vaccine against this virus is what we know from the flu. It's going to reduce the severity of the disease, and it may reduce hospitalizations and death, but it may not stop the spread of the disease, because we haven't seen any vaccines actually stop the spread of the flu. Now, this would be a good thing to do. It's worth. But I think the idea that a vaccine is going to just make this disease go away altogether is probably premature, especially if you look at the literature from veterinarians. So coronaviruses are very common in dogs and cats. Veterinarians have had a vaccine against coronaviruses in dogs and cats for many years. And their experience with that vaccine is that it works a little bit, but it does not fully protect dogs and cats from acquiring coronaviruses. And it may make the disease less. The other interesting thing is that in cats, coronavirus infections have somewhat similar situation to humans in that some cats have no symptoms and other cats just get sick and die. They die of an overall inflammatory response that nobody can control, which seems to be what's going on in humans. So it obviously makes sense that what you would really like to do is find out why some people get really acutely ill. That would be key, and other people seem to get infected and have 60% of people who get infected don't seem to have any symptoms whatsoever, including children. Now, the good news is that this virus has a very specific place on a cell that it must bind to infect the cell. It's not random like the flu virus. And so therefore, an effective vaccine, everybody's hoping that because of this specificity, it'll be easier to make a vaccine. The binding site is this thing called ACE2, and you've probably heard about that in the news. ACE stands for angiotensin converting enzyme type 2, as opposed to angiotensin converting enzyme type 1. And angiotensin is a hormone that is very active in regulating blood pressure. So it's angiotensin that makes your blood pressure go up and down. People who are on blood pressure medications frequently call it an ACE inhibitor. And this is the receptor that it's inhibiting if you're on anti-blood pressure medication. So this is why COVID-19 is actually a vascular disease. It's not an upper respiratory disease like the flu. It's a vascular disease, which means it can affect a lot more organs in your body. It's one of the reasons that things have happened, like people get strokes have been reported. It affects basically and infects blood vessels. That's the major thing. It also affects probably the gastrointestinal tract, which also has some ACE2 receptors. So any cell type, I think it's also, we're going to learn that this is probably not the only receptor, that there might be one or two others. But it's not a general cell surface thing like it is with the flu. So there's a huge, like many things, this whole COVID-19 has become a very hot political topic. And so what actually did we get right? What did this country get right? Banning the travel from China on January 31st when there were only 7 reported cases in the country, was an extraordinary action. It was very unpopular. Nobody really thought it was going to be necessary. At that point in time, the Massachusetts Department of Public Health was telling everybody that there was no risk of this disease in Massachusetts. And that's what departments of public health were telling people all over the country, that there was no risk of this virus getting into the US. So just putting a ban on travel from China that early in the pandemic was an extraordinary thing to do. The first case was in Washington State. It was a guy who had returned from visiting his family in Wuhan. That was January 15. The second case was a woman from Chicago, also returning from Wuhan, and she infected her husband. And so it was basically only, and then there were 5 other cases that were kind of maybes, not even total. And this ban went into place Sunday evening, February 2. Then the first confirmed death was February 6. And at that point in time, the CDC looked back through its data and decided maybe there'd been other deaths prior to February 6. February 29 was when the Food and Drug Administration issued guidance to all federally licensed laboratories. That happened to be a Saturday morning, and that was the Saturday morning after the Friday before was the very first report that hit the news that in Washington State, there was the first report of serious infections in a long-term care facility. And they were calling this the first community-acquired infection. In other words, it was not linked to somebody who had just come back from China. It was linked to the community infection of some kind. When I heard that, I actually reached out to somebody that I know at the Centers for Disease Control and said, do you guys need help? And the next morning when I talked to somebody there is when they explained to me that their restriction was that they could only work with laboratories in their network. And the Centers for Disease Control network is restricted mostly to departments of public health. So there were maybe only 60 laboratories in the whole country that were part of the Centers for Disease Control's network. So they were they'd spend all of January frantically trying to develop a test, but they still only had 60 laboratories that they could dispense it to. And then, as many of you, as we learned, in their haste, they sent out some wrong reagents, and the test results were all over the map, and nobody could trust them, and that created a huge problem. But the basic fundamental problem was the way the federal public health system was set up, is that the CDC can only work with their network. And so that's why the FDA issued guidance to all federally licensed laboratories, and there are thousands of us, to see if we could develop a SARS-CoV-2 test. They had some guidance. They wanted us as much as possible to use what the CDC had designed. It wasn't the reagents that the CDC set out, but they had designed the test. The World Health Organization website had a very good posting of all of the various virus tests that had been developed all over the world. Germany posted its test. South Korea posted its test, Japan posted their test, China posted their test. And so there were lots of places that you could go to if you simply wanted to figure out how to design this test. So that happened in late February. It would have been better probably if it had happened in early February. That would have been better. And then we banned travel from all 26 European countries March 13. Should that have happened in February? Perhaps. All travel bans were highly criticized. It was very unpopular to put travel bans in place. And so it was probably surprising that it even happened in mid-March. By late March, 2 military hospital ships had been deployed, one to Los Angeles and one to New York Harbor. Should that have happened in early March? Perhaps. That kind of deployment can't take place until the governors ask for it. So some of the nuances around public health have to do with the fact that public health resides with states. Our national public health system does not reside in the federal government. It resides with states. So states have to organize it and they have to reach out. By April 3rd, and this was a long time that it finally happened, the CDC began to advise face covering usage. I think it's important to note that Sweden has never advocated to use masks. You can make a very strong case for the fact that people who wear masks and don't know how to wear them, or don't know how to dispose of them, or don't know how to keep their hands off of them when they're wearing them, have a chance of spreading more virus than protecting everybody. So it really requires some practice in knowing how to use masks to keep it safe. And all the Swedish government did was they recommended social distancing, they recommended hand sanitation, they recommended don't touch your face, and they cleaned all of their public transportation facilities very often. They recommended wiping doorknobs, they recommended all the things that you would do. But in their view, when people put on masks, first of all, if you don't know how to use them and you're infected, you can get all of that virus covering your hands, and then anything your hands touch is now a much more concentrated than it was. And it makes you feel safer than you are. So by not wearing masks, people tend to stay apart, they tend to stay away, and they tend to just need to keep everybody washing their hands. And then by April 8, the government they invoked some kind of war act and forced General Motors and Ford to retool their factories to build critical care ventilators. And most of those, I don't think, were ever actually needed. So what did we do wrong? Why did this get so out of hand? The biggest thing that we did wrong was we allowed stockpiles of emergency supplies to be depleted over decades. This didn't happen last year. This happened 2 decades ago. It actually happened after we sent a bunch of them off for either the Ebola virus or another viral pandemic. We donated a bunch of our masks, and they were just never replaced. 2 decades, at least, maybe 3 decades, public health experts have said the design of our public health system could not respond to a global pandemic. And part of that problem is that a lot of our laboratory technology has been developed as, quote, high throughput. So if you want a blood test for $8, you put that in a machine, and that machine requires very specific reagents to function. And most of the reagents that fuel our clinical laboratory instruments are made someplace else. They're made in South Korea. They're made in India is a big source. They're made in China. And so we don't have the infrastructure in the States to create it's like inkjet printers. Your neighbor's inkjet cartridge is not going to fit in your inkjet printer. So those are the kinds of reagents that are needed for high throughput instruments, and we aren't making them here, and we didn't have enough of them, and they're not stockpiled. And the other problem that we had is that epidemiologists were way too in charge of this epidemic at the beginning. And I think a really good example of that is what happened in Massachusetts. I don't know if you guys read the really good Globe article on what went on in Massachusetts in early March. It's worth reading, because there was the physician in Central Mass was pretty sure, she was an infectious disease expert, and she was pretty sure she had a tiny outbreak of coronavirus infections. And it took her 2 weeks to get the Massachusetts Department of Public Health to agree to get a test done. 2 weeks of people, a little group of people who were infected in Central Mass that went undiagnosed, even though this physician had read on the CDC and they had all the symptoms of COVID-19. She couldn't get a test done. And then the other problem that happened after the outbreak in downtown Boston by the high-tech company Biogen's conference, where they had a lot of people infected, they couldn't get tested because you need it in Massachusetts. You have to have a physician-signed test requisition to get a test. And they couldn't get that because they didn't have symptoms. So the 50 or 200 people who attended that conference, all of whom wanted to get tested because they were aware of the risk, it couldn't happen. Couldn't happen in Massachusetts as quickly as it needed. Then the other thing was the whole problem around swab production. That got to be a nightmare all over the country. And it turned out that there were only 2 places in the entire world that make medical swabs. One of them is in Maine, Puritan Medical Supplies, and the other one was in Italy. Italy turns out to have a manufacturing plant for swabs. And of course, Italy got shut down very early. And the pandemic hit Italy very hard because there was a high fashion meeting in Milan in early January. And a lot of high fashion design, clothing design companies have been purchased by Chinese businessmen. And so there was a huge group of the Chinese that gathered in Milan in January. And that started their little outflow of disease. So Italy's swabs were very difficult to get because not only did they need them, the communication with Italy had been shut down. So it was not until late April that Puritan Medical Supplies in Maine actually got government funds to up their swab production. So as something as trivial as swabs actually really delayed testing. And then we delayed mass usage guidelines. The CDC came out with early guidance that said, don't do it. And then there was other guidance that said, do it. So the confusion around that, and the confusion around that still exists. I wanted to remind you really quickly of the coronavirus life cycle. It's more complicated than the flu, and that allows it. So here is, you can see where the virus is sitting down on this word called receptor. I don't seem to have any kind of a pointer. And so that is very specific. And all the little steps inside this cell are all targets for some kind of pharmaceutical intervention. So everything that the virus needs to produce new virus particles is a target for a drug. And I think that's one of the things that we're not doing enough now. All the focus is on a vaccine, and we need to divide some of that focus on those resources to developing some antiviral medications. I'm a little partial to that because I've watched for 30 years, I've watched vaccine developers fail to develop a vaccine against HIV disease. I think we're on vaccine trial number 81. And so HIV disease is controlled by 24 different drugs. And we developed 24 new antiviral medications in 20 years when we put our mind to it. So it's clear to me that we could, if we put out the energy and put out the call, and our National Institutes of Health does not involve itself in drug discovery. It has to be forced into funding drug discovery. And it was the brave people who were dying of HIV disease that went down to Washington, sat on the lawn in front of the National Institutes of Allergy and Infectious Diseases and said, do something, we're dying. And a vaccine isn't going to save us. And so at that point, the NIH released a lot of resources for drug discovery. And that's how a team between basic scientists and the pharmacy apparatus, the pharmaceutical companies, developed 24 drugs, 24 new drugs in 2 decades. So that's why HIV is controlled. The same story is similar for hepatitis C. A vaccine was never developed against hepatitis C. Hepatitis C is now actually cured by pharmaceutical treatment. So what are the important next steps to do? So vaccine development seems to be well underway. Almost everybody is developing a vaccine against the spike protein. See the word there that says spike protein? That's the little knob on the surface of the virus that has to hook into the cell. This is kind of like the hook and like an opening and closing a door. Most of them are going to stimulate an immune response against the spike protein, so it can't bind to the cell. That's the basic plan. Others that are being developed are going to promote immune response to most of the virus. So remember, if you hearken back to the polio virus, I mean, we got hooked on vaccines because poliovirus and chickenpox, poliovirus and smallpox vaccination was so successful. And each of those, the vaccine that was created by just hard work in the lab to come up with a virus that was defective, and it didn't spread. And so you kept selecting for the virus particle that was defective. And that's what they call it, a live attenuated virus, the early one that we got for the polio virus. And it worked. It had some side effects. Some people actually got paralyzed from that vaccine. And then the second generation, the virus was more defective, couldn't infect. It was not a very, very good infection. But those viruses were built on the idea that you would have an immune response against the whole virus, not just one or two parts of the virus. I think antiviral medications are urgently needed. As I mentioned, HIV and hepatitis C are currently controlled or cured, in the case of hepatitis C, cured by medications. So I think it's really important to not put all of our resources into just vaccine development. And we need to know where this virus has come from. That's urgently needed. The pandemic has clarified what public health experts have always known, that a brand new virus introduced into the human population could devastate it. And so this particular virus is remarkably contagious. It's almost as contagious as measles, which is much more. So public health experts rank a virus according to how many people one infected person will infect. So for instance, if you get the flu, on average, you're only going to infect one other person. If you get SARS-2 infected, it looks as though you can infect up to 12 or 20 people, because you're going to be infectious before you have any symptoms. So this virus is particularly easily transmitted, and it's particularly easy to get infected. So there's a lot of experts now that are looking at this, because it probably came from a bat. That's, I think, undeniable now. We know that this is basically a bat virus. But viruses that cross species generally take a lot longer to adapt to their new species. They kind of mull around for a while, and then they get stronger and stronger. This one obviously has roared all over the world really fast. And this has given rise to some conspiracy theories. And I looked a little bit at some of the conspiracy theories, and as you can imagine, they're all very political. But I think we really, really, really do need to know where it came from. Bats have a huge repertoire of coronaviruses. Bats live in colonies of thousands, and they pass these viruses around to each other. There are 2 or 3 candidate bat viruses that seem to be the basic backbone of this new virus. There's a debate as to which one it is. It probably did not come from somebody being infected at the market in China, where they sell live bats for food, I guess. I don't know. That probably is not where it came from. The Chinese and other laboratories too have been trying to develop a vaccine against the SARS family of coronaviruses ever since their big outbreak in 2003. So this is not new research. The Centers for Disease Control has a report posted on its website of the interesting high infectivity containment facilities called a BL4. Remember when Boston University built a BL4 containment facility in downtown Boston? So this is what they've developed at the University of Wuhan. It's going to be their vaccine development. They have a BL4 facility, and they posted on the CDC's website all the things that they had done to set this facility up. And the purpose of this facility is to develop a vaccine against SARS or any similar type of virus, because they have a lot of bat viruses circulating in China. Now, when you do that, when you want to study a virus, one of the things that you do is you've got to develop a laboratory system to amplify that virus. You can't just keep infecting bats and then isolating the virus out of the bats. It's very slow and it doesn't work very well. So if you were going to develop a virus against a human vaccine against a virus, you would probably want that virus to adapt itself and to multiply in human cells in culture. That would be a routine research approach to doing this. But now if you keep, and you can do that by genetic engineering, probably. We have no idea whether that's happened in this case. Or you can do it simply by continuing to culture the virus over and over and over in the culture system that you want. They've been working on this in the BL2. They set that up in about 2005 or 6, I think. So they've been working on this for a very long time. Could a virus have been adapted to human cells? Possibly. We don't know that. And this is something that we really need to know. We really need to know where this virus came from in order to prepare for the fact if this ever happens again. To think that this is just a one-time event is a little bit naive, considering how much travel goes on in this day and age. Now, was this deliberately released by presumably the Chinese government to cause a pandemic and worldwide economic turmoil? There's no evidence for that. Whether that's going to prove to be the case, we don't know. But I think that is a conspiracy theory that doesn't deserve a lot of attention right now. I also don't think a conspiracy theory in which Chinese scientists deliberately did this is useful. I do think it's really important that we understand exactly where this virus came from and how soon somebody knew it was as infectious as it was. I think I'm going to stop there in case anybody has any questions, because I think I've talked a little longer than I was supposed to.
Thank you, Anne. Am I audible?
Yes, Ellen, we can hear you.
I'm sorry. Thank you, Anne. We really appreciate this insight. A lot of things to grasp, especially for people who are not as scientifically knowledgeable as people who are now studying viruses and in college at this point. But I think the points you've made are fantastic, that this is a virus that, when compared to the flu, has a lot of differences. I don't want to profess to repeat what you've said or emphasized in any way. I want to just thank you very much for taking the time to put these slides together and to present to us. For those people who are new to the whole Lyceum idea, I wanted to let people know that we are planning to have these sessions once a month. And I wanted to now turn it over to Q&A. I'm sure we have a bunch of people. If you are interested in asking a question of Dr. Kiessling, if you could raise your hand in the participant, using the participant function, or chat with us now and just let us know. So I see 3 people have raised their hands.
So Ellen, I'll basically keep track of kind of the ordering, and then I kind of mute and unmute as needed.
Yes, and I also want to excuse myself for fumbling a little bit. This is the first time I've been helping to run these talks. And let's see. Who's the first person who raised their hands, Delcy?
So the first one was Rich.
Okay.
So I'm going to ask you to unmute Rich.
Okay, I think I'm unmuted.
Hi, Rich.
And about 2 months ago, either in conversation someplace or in a formal setting like this, I think I heard you say, for the United States at least, the only way out of this is for everybody to get it and either die or get well, or develop a vaccine that everybody that wants to live subjects themselves to. Is that still your, let's don't say it's a belief, but opinion?
Rich, I still think that everybody's going to get this. I still believe that. I don't know, hopefully it's good, by the time everybody does get it, we'll have a lot better ways to treat it. The death rate from this, even for people who are seriously ill, is going down very quickly because everybody's learning how to keep people alive. And there's been a lot of, there's not any specific pharmaceuticals right now, but there's been a lot of improvement in keeping people's lungs clearer. So you take care of their long-term care facilities well enough, that they probably have developed more herd immunity than anybody else on the planet.
A follow-on question, if I may. And are you aware of a reputable worldwide scientific body that is preparing sort of a Monday morning quarterback white paper that says, you government, you idiots, you killed way too many people than what should have been killed by this?
Which government would you point to? Yeah. Would you point to Brazil? Would you point to even China? I mean, which government? You mean our government?
Oh, ours, U.S. government.
Oh, well, the U.S. government started failing this 2 or 3 decades ago, when everybody seemed to have decided that this was not going to happen because we were too good at vaccines and antibiotics, and we just didn't need this public health infrastructure, so we didn't keep it up. We don't even have public health nurses very much anymore. So the failure to maintain our public health infrastructure began decades ago.
Okay, thanks, Ann.
All right, next in the queue, I think we have Bea Brunkhorst. So Bea, I'm going to unmute you.
Thanks.
Hi, Bea.
Hi. I'm sorry I was a little late, but excellent talk. Just wanted to say that there are a number of clinical trials going on for therapeutics. I know that some monoclonal antibodies have started now in clinical trials. I work for German Merck. We're trying right now in clinical trials as our multiple sclerosis drug in combination with remdesivir. And I also know there are grant programs looking for the next mutation of the virus as well. So there is work. I don't know if it's enough, but you know, there is some work going on trying to get therapeutics, you know, so to obviously to keep people off respirators, to treat people.
Great.
Just say that.
All right, so I guess there's no further question. We'll move on to Abby Hafer. Abby, I'm going to unmute you.
Hi, Ann. Thanks very much for your talk. I'm going to ask a little bit of a technical question. You were talking about the ACE2 receptors and the cells that have the ACE2 receptors. Now, are that type of cell, or is that type of receptor, more to the point, they're kind of widespread throughout the body. Are they found only in the type of tissue called epithelial tissue, or are they found in other types of tissue as well?
They're found mostly in vascular tissue. So
right.
The internal surface of vascular tissue is
okay, the internal surface was the part I was interested in, because that would mean epithelial, basically. Okay, so internal surface of vascular tissue. Which
and also, for some reason, in the testis.
What's that? Oh, right. Well, there are ACE2 receptors in testes.
Yeah.
But on the other hand, they're also largely epithelial cells. So this is why I was wondering if this was specifically an epithelial cell thing.
I don't know. I don't think skin has a lot of them.
Uh-huh.
But it's basically a vascular disease, not a lung disease. It's not an upper respiratory disease. It's a vascular disease. The lungs just happen to get really hard hit.
Well, it's a point of entry. Okay, thank you.
All right, thanks, Abby. So we'll move on to Jerry and Kathy. And then I also do see, Rich, you had another hand up, and I think we have a question from Ellen as well. So go ahead, Jerry and Kathy.
Okay, thanks, Dan, Ann, for an extraordinarily thorough and informative presentation. Could you revisit the mask issue one more time? At one point, I thought I heard you talking about masks not being very effective unless you know how to use them. And there's lots of problems with that. Then in terms of sort of what we did right and wrong, it sounded like an earlier, wider use of masks would have been helpful. So could you say a little more?
So the big problem that we had for masks early on was that we didn't have enough for healthcare workers, right? So if you're a healthcare worker, you know how to use a mask. You know how to, so if you talk to people, that one of the big complaints about masks is they fog my glasses, right? Well, if the mask is fogging your glasses, you're not using it right. And you don't obviously know how to use it because obviously you're breathing around your mask. So the problem with just standardized, I mean, it's the reason that the first thing out of Tony Fauci's mouth was not everybody should wear masks. It's because it's a complicated topic. And if you do studies to see what kinds of viruses go through what kinds of masks, the data are very confused. If somebody sneezes, those are big wet droplets and a mask will contain that. If you're just breathing regularly, a lot of virus is going to go through the mask. So does the mask block how wide the dissemination is of virus from somebody who's infected? Probably. But if that person doesn't know exactly how to wear the mask, they're breathing around the mask anyway. And if you fill that mask up with virus, say you're infected and you don't know it. So you're wearing a mask at the grocery store. You're fiddling with that mask almost all the way through the grocery store because it's fogging up your glasses and you can't see the price of anything. And now you've concentrated some of the virus in that mask. Now you're touching it all the time with your hands. So now where your breath would have spread this virus all over the floor 6 feet in front of you, you now can spread it all over with your hands. Now, population-based mask usage, if everybody wears a mask, is it going to help? Maybe, probably. But the biggest problem early on is that we didn't have enough masks for people who do know how to use them, who really could have benefited from that. So if you were in a hospital and you were transporting somebody and you knew this person was positive for virus, you needed the kind of mask that you could put on a patient just to keep them from spreading it through the hospital. We didn't have those masks. So that was a big problem. It's very possible that for the general public, a more appropriate protection is a shield, is a face shield. So I think, so mask use, it's become very politicized now, right? I mean, if you're a good citizen, you're going to wear a mask, and if you're a bad citizen, you're not wearing a mask. Right. And that's really, it's not that simple. And there's two big problems with masks, is that if you don't know how to wear them, and you don't know how to handle it once it's contaminated. I mean, most people leave them in the front seat of their car, or stuff them back in their pocket, or put them in their pocketbook, because we're just wearing them because it's now the socially accepted thing to do, right? The other problem with masks is that it might have people feel too protected. So now when you get on that elevator, you're standing too close to somebody. Or now when you go to a Trump rally, you're standing too close to that person next to you. So it creates kind of a false sense of maybe security behind a barrier. So I think big population studies indicate it might help, but I think there's not nearly enough education behind mask usage to make them really effective. Can you see how complicated it really is?
Yes, I was going to ask you for a quick course on how to wear a mask correctly, but I have a feeling that may not be possible.
You should fiddle with your mask until it doesn't fog your glasses. And then when you take it off, don't touch it, right? And then put it someplace. Assume you're infected. Now, if you're wearing it to protect you from somebody else, that is really false security, a false sense of security. Does it protect you? Maybe a little bit. Would a shield protect you more? Maybe. Shields are pretty unwieldy and difficult to use. So the social distancing piece of this is probably far more effective. And that's what they promoted in Sweden. I think they had some limits on how many people could get together. The governor's limits on people getting together is probably a good way to do it. What we really obviously need are some more point of use tests that are really rapid. There's actually a little company in Bedford that has just entered. It's not such a little company. It's around the corner on D'Angelo Drive, and they've just entered the X Prize. And they're trying to develop a $1 point of use 20-minute test. So wish them luck.
Thanks.
All right. So we have a couple more questions in the queue. Ellen, shall we keep going with those?
Yes, please.
Okay. So I'm actually going to call on, if you don't mind, Rich Suval. I see Rich Doherty, you also have your hand up, but since Suval hasn't had a chance, we're going to let him get a question in. So I'm going to unmute you, Rich Suval.
Good. Okay. Thank you, Anne. Anne, I'd like you to put on your, look into your crystal ball and tell me, when can I go back to see the Boston Symphony Orchestra?
I think, one of the problems that I have, and I'm not an epidemiologist, and my public health experience is really sort of like, learn as you go kind of thing. The problem that we're having right now is that we've got way too many people, it seems like, in the higher levels of our government that aren't talking to each other. So if you look at the guidance for preschools to open up, that's one group of people. If you look at the guidance for high schools to open up, that's a different set of people, and it's a different set of guidelines. And if you look at the guidance in Massachusetts for higher education, that's a different set of guidelines altogether. And if you look at the guidelines for when you can go see your mom in the nursing home, that's a totally different set of people. So I don't know who's going to decide when the Boston Symphony can open up again. I would think the orchestra itself would treat itself as a sports team, and they would develop some kind of testing system so that they could get up on the stage and play together, even if everybody else has to just Zoom call in to watch it or whatever. I'm surprised that hasn't happened. I'm surprised that neither the symphony nor the Pops have kind of gotten their act together to do a testing program that would allow them to get together. But I think, Rich, the problem in Massachusetts is there's a lot of chiefs and they don't seem to talk to each other.
Thank you.
All right. Ellen, I think you said you had a question yourself.
Yes, I did. I know that after getting COVID-19 and surviving it, there are many after effects that have been in the news, and we actually know someone from the VA who is having all kinds of complications post-recovery. When you talk about therapeutics and treatment, if they can be focused on rather than a vaccine for the immediate future, are you thinking that the same therapeutics could be used as an after recovery, as well as to treat the acute illness?
I don't know, actually. I mean, it's going to be an organ by organ. The lung gets really hit because it's so vascular and it requires so much blood supply to maintain its function. Kidneys are going to be hit. So it kind of depends on what organ system is involved post-COVID. I think it's important to remember that more than half of the people who get infected have no symptoms and no after nothing going on afterward. I know there's occasional anecdotal stories of this person had no symptoms and now 6 months later they still have shadows on their lung. I know those stories are out there. I think they really are very anecdotal. And I think that the treatment post infection is going to have to be an organ systems design treatment.
Thank you. Thank you so much, Anne. Hey, Delcy, why don't we just go to the final slides if there are no other questions. I just wanted to thank everyone for participating, and Anne, thank you so much for your expertise and your patience with us. As I mentioned earlier, we're hoping to have the Lyceum presentations, which are free and open to the public, on a monthly basis. We already have a presentation lined up on Sunday, October 11th, regarding the climate crisis. Is Corinne on the call? Okay. I'm sorry?
We may need to unmute her. Let me see if she.
Oh, sorry. Thank you.
Let me see if I can find her. Yep, I'm going to unmute you, Corinne.
Could you give us a 1 second, or I'm sorry, 1 minute summary of what you're planning to do?
Hi, sure, yes. So I'll be presenting a slideshow on climate change that Al Gore created, and it touches on the science, societal changes, and solutions to curb global warming. So I hope to see you at the Lyceum on October 11th. Do I have time for another quick announcement?
Sure.
The church common read for the climate book by Naomi Klein was going to be in October, but the Environmental Justice Committee met this week and decided it would be better to have the book discussions after the elections are over. So the book discussions are going to be in January, not October. Thank you.
Great. So if we want to make a note of that, we can put a little asterisk when we send out the announcement about the with the link for your talk on October 11th. Okay.
And Ellen, we have a question in chat to clarify the time for October 11. Is that known yet?
Yes, it's 4 o'clock again.
Okay.
We're waiting to get confirmation on a date for December, but Brad Connor, our music director, has put forward a proposal to have a second talk about Beethoven on the 250th anniversary of Beethoven's birth. And in November, we don't have a speaker yet. I just wanted to encourage people who have participated today, if they have topics or speakers they'd like to suggest for future presentations, those are all welcome. My email address is mountainbreeze52@gmail.com, and we're open to your ideas. And the last slide, please, Delcy. Oh, next to last slide. These Zoom presentations are free and open to the public. If you're interested in supporting these, because we do have a Zoom license that the church has been kind enough to allow us to use, you can make a donation electronically or send one by mail via check to First Parish in Bedford. And then the last slide, I just wanted to thank everyone who's helped technically, Delcy Sherrill and Bob Bass and Bob Batt. They're going to help us with loading this recording into YouTube. So with that, we'll close today's Lyceum. Thank you very much. And for those who would like me to give that email address again, there's one gentleman please stay on for the moment after we close the regular session.
I can post that address to text too.
Oh, that would be
In case
great.
People can check the chat.
Thank you.
I posted the link to the donate site in chat, as well as our usual donate by text. If people would like to donate that way.
Thank you. So you're putting that into the chat?
I am. I just have to do a copy paste.
I'm sorry.
There we go. Yes, there we are.
So the next Lyceum will be advertised through distributions to the UU congregations in the area. We're hoping to get an entry into the Bedford Citizen. And if you're on our mailing list through the church, it'll be in our what we call our parishioner as well as by email. Thank you very much, everyone. And thank you, Delcy.
Very welcome.
Thank you, Anne.
Thank you, Anne.
Welcome.